Yes, welcome to this economics. Today we're going to look on how we interpret the meaning of y-intercept and beta 1 in the regression model. Beta 1 is the slope coefficients in the linear regression model. So in a fitting set line data set of yield, the following prediction lines were given. We are given the y estimated is equal to 6 plus 1.4x1, and we require to interpret the meaning of y-intercept, to interpret the meaning of the slope beta 1 and predict the values of y for x, which is 3.5. Solution. Now suppose the regression we are required to, for the part A, to bring out the meaning of y-intercepts, or sometimes called the beta naught. So from our regression model, we have y estimated is equal to 6 plus 1.4x1, 1.4 beta 1, this is the slope coefficients, and 6 is a beta naught. And y, in the given function of y is equal to mx plus c, we observe the m is the slope and c the intercepts. So y is a dependent variable and x1 is a dependent variable, or sometimes called the explanatory variable. So y-intercept is actual observed to be 6 as we observe. So it is equal to beta naught. So the beta naught actual is 6, which is the y-intercept. So when we interpret the y-intercept beta naught, this is a constant value. That is the result of x, which is equal to 0. And actually it does not, the intercepts of beta naught, it actually implies that it does not cause any change towards the changes of dependent variable or independent variable, or sometimes explanatory variable. So that is how it is. Also, what you need to understand here, what about a beta 1s, that is a coefficients? How do we interpret the coefficients? The beta 1, the slope coefficient, that is 1.4. So this is how we do. So for part B, as I told you, we are required to interpret the slope coefficient, the meaning of beta 1, the slope coefficient, that is 1.4 in our regression model. So suppose we have now y estimated is equal to 6 plus 1.4x1. We understand the slope coefficient, that is 1.4. So the y estimated is equal to beta naught plus beta 1x1. So when we consider now to look on where 1.4 the slope coefficient position, we actually understand this the slope coefficient 1.4 implies that an increase in 1 unit of x1, that is a dependent variable, implies also there will be an increase, the same increase amount of dependent variable, that is y estimated as you observe, to the same amount of unit. So the slope coefficient 1.4 implies that when x1 increases by 1 unit, it leads also to y estimated to increase with the same amount of unit. So actually we interpret this because our value is positive. If we could obtain the negative side, we could interpret different from this meaning as you observe. So the slope coefficient 1.4 implies that when x1 increased by 1 unit, it leads also to y estimated to increase the same amount of unit. Now part C, we are required to predict about the y, the estimated, the predictable variable y, when we are given x, the independent variable. So how do we interpret the values of y when we are given x is equal to 3.5? Now solution, we consider to take out our regression model estimated, that is 6 plus 1.4x1. We plug in our x1, that is 3.5. Now our predictable variable y estimated will be equal to 6 plus, we check our 1.4 times 3.5, which will give 4.9. So the answer will be equals to, we take out 6 plus 4.9, that is 10.9. So our y estimated is equal to 10.9 as we observe. So this is the predictable variable when given the independent variable is 3.5 as you observe. So that is how we perform the question. So I welcome you to also other videos to cross-check on more regression analysis, and I welcome you to DC Economics. Don't forget to subscribe my channel